Okay, welcome back. Let's go to page 1030 and start talking about virtual private networks. So there's a lot of ways you can tunnel between out of an insecure location. So, for example, when I go on holiday, I go to Holiday Inn Express, and when they give me my little key card, written on the sleeve of the key card is the password to the Wi-Fi, and the password is pancake, which means everyone in there could have access to the Wi-Fi because everyone knows what the password is. So is that smart? Whew, not really, huh? So what I need to do is I need to VPN out of that insecure area and then jump back on the internet and get the heck out of there. So I use a VPN client that gets me out of my insecure area, and then after that part has happened, then it's just exposed to the internet like everyone else. So that's one type of tunneling. I tunnel through the part that I don't like, and then I daylight and walk the rest of the way. Now there's another type where it's a permanent connection, where I have a business over here in Cincinnati and one in Dallas, and I want to connect the two together. Well, this is a permanent connection, so I can have all the traffic that's meant to come over here just go through this VPN tunnel, and that way it doesn't daylight anywhere. It stays encrypted all the way end to end until I get from my safe. It starts inside my safe LAN over here and ends up inside my safe LAN over here. So in no time am I exposed to the internet at all, okay? But those are typically permanent connections, right? You don't just set those guys up and tear them down, because you have to have like specialized hardware and stuff to make that happen. Kind of make sense? So there's one called a transport mode and a tunnel mode. And so which one is the point to point? Which one is the one that requires the hardware and the special configuration that's not designed to be permanent and all that? Okay. So is the VPN software all you need? Well, to tell you the truth, the software is free. OpenVPN. So you might think, wait a minute. I'm paying Norton or I'm paying Nord for a VPN. Why am I paying if the software is free? Well, you're not paying for that part. What you're paying for is the server at the other end, right? Because when I want to tunnel out from an unsecure area, I want to dig down, tunnel through the dirt, and then come up at a server somewhere. Hopefully a server somewhere near me. That's what I'm paying for, is that server at the other end. Okay, that's what I'm paying for. Cool. On page 1031, they talk about certifications and standard. The Certified Information System Security Professional. Yes, CISSP. That is the gold standard for doing this. I mean, it is probably the one. If you were thinking, well, I think I'm going to get a security one, well, you really need to do that one. There's another one called Global Information Assurance Certification, GIAC. It's from the SANS Institute. Now, there are some problems with some of these things, and that is, there's a lot of people have what's called paper certs. Okay, paper cert is a derogatory term, basically meaning that, yeah, you went and got the certification, but you don't know jack. So, for example, the CISSP requires 5 years of experience. It requires a 4-year bachelor's degree. They're serious, okay? They are serious. They don't just pass those things out because you passed an exam. You got to show that you actually know your stuff more than just passing some goofy exam. ISO standards 27,000 is widely accepted everywhere. The payment card industry, PCI, data security standards, PCI DSS, a very good standard. If your company or organization is capturing user data, particularly credit card data, or any type of privacy data, if you're getting their name and their password and their street address and phone number or anything about them, well, then you probably need to be using that. The NIST series. So if you're in the security class, I make you do an entire NIST 800 style security plan. There's all sorts of templates for this stuff. It's actually pretty easy. Sources of how to get this information. So on page 1035, they talk about different places you can go. So there's one called the Schneider I can't pronounce that. Schneider blog. And this is a good one. Okay, there's lots of them out there. It's just this is the one that was mentioned in the book. Bug Track and a bunch of other stuff. One of the ones I like is called the DIBR. This is the Data Breach Investigation Report, the DIBR. And so here's an example of the DIBR, where you can download the report and find out what essentially is going on these days. What kind of, who's being attacked? Well, outsiders, internal people, partners, multiple parties, organized crime, how's it being used? Hacking, social attacks, malware, So this is useful information because you might be thinking about or pointing to, you might be thinking, well, I need to spend more time on, outsiders. But it turns out 34% of your problem is from people inside your own dang building. Okay. So there's an annual report that's very useful. It basically talks about the trends. For example, in the recent time, organized crime has kind of been in here a little more because of the malware stuff. Okay. The SANS Institute. SANS used to mean something. It used to be Sysadmin, Audit, Network, and Security, but they don't call themselves that anymore. Now it's just an acronym, SANS. Okay, so cool. So on page 1037, they kind of cut it down to this numbered list saying basically, okay, I've been attacked. What do I do? And so this list is actually pretty doggone good. The first one is don't panic. Okay, everything's okay. Don't panic. Decide on what kind of response you're going to have. Are you going to do something really nasty, or are you going to just, clean up after yourself? Get the tracking information so you can use it to do further investigation, because you really want to know where it came from. You very, very much need to know this kind of information about, did it come from the outside? If so, I need to tighten up something, right? Determine your exposure. How exposed are you now with the breach? Do you have to do something? Are you obligated under some rules to tell people? Do you have to? Maybe you should pull the plug. Your file server where very, very sensitive information is being stored and somebody's attacking it, will just pull the network cord. That might work. You need a recovery plan, how to get things back. You need to communicate the recovery. You basically need to say, we had a breach and here's how we solved it, and here's how we're getting things put back together. You need to implement the recovery because you can't really do it, right? And then the last one is reporting the incident. Now, this is complicated. Okay. People are encouraged to report incidents like this, but unless there's been some, in some countries, it's a requirement. I believe in the EU, if you have more than whatever it is, so many $1 million, you're a big enough company that anytime you have some sort of a data breach, you're obligated to do that. In the U.S., the rules are not quite as tight. And so it is possible you may decide not to report something because you're embarrassed, okay? Now that typically never works in your favor if you get caught, okay? I'm just saying, right? That's just a dumb idea. And the other thing is, if you call the police or the FBI, it's no longer your scenario anymore. You don't get to choose, when the server comes back up. Because they're going to be, no, you can't touch that. It's part of an ongoing investigation. You go, oh boy, right? So unless you had a spare server somewhere, you might consider that one a lot. Okay, I'm moving on to chapter 29. So chapter 29 is talked about performance. So page 1070. So you might want to say, well, first of all, performance analysis, is that an art or a science? Well, that's a little bit of both. The science is you need to know what it is you're trying to measure. And then the art is I need to balance all the resources among all the competitors for that resource. And that takes a lot of skill and experience. It's not straightforward at all. You might think, well, hell, I'll just add more memory or add more CPU or whatever the heck it is. Add more disk or more network cards. But, the problem is if you start down that road of just, upgrading hardware, without first finding out what the heck the problem is, you might be spending a heck of a lot of money upgrading something that don't need to be upgraded. Okay, just saying. So when people come in and say, hey man, the server's slow, we need to add more memory, I'll go, oh yeah? Are you sure it's a memory? And they go, well, isn't it obvious? And I said, no, it's not. You need to go back and do your work. Come back. Okay. So there's some philosophy, of course, on page 1071. So sometimes you have detailed information on the inner workings of something. Like there's source code that's available. You can actually go poke around inside and see something. That would be amazing. But the operating system is fairly loose, and you can go in and tweak certain things in the operating system. But I will tell you right up front, unless you are an experienced developer, don't do this. Okay, I'm just saying, don't do it. Yes, you can go in and change the buffer pools and the OS paging and all the rest of that stuff. The reason is making tweaks to the operating system is most likely not going to solve the problem. Most likely it's the application that's causing the issue. Let's say, for example, you have a web server or a database server of some sort. Let's say a database server. And the database server is just beating the hell out of this poor old machine. And you might say, well, I need to add more CPU. Well, maybe there's something you can tweak in the database, not the operating system, not the hardware. Maybe there's something else you can do. Okay, just saying. So there's some rules. Here's the rules. The first rule is you need to collect historical data as a baseline. So when you first install this database, you need to collect some data on how it looks brand new out of the box. Okay? How fast does it respond to requests for, SQL statements? If it's 12 milliseconds, you write that down. That, the day of install, it took 12 milliseconds to do this. Okay. Then you use monitoring tools like VMstat and TOP and all those guys we talked about in some previous videos, where you're gathering current information. And then you want to make tuning changes based upon the baseline. Okay? Because if out of the box, the best it can do is 12 milliseconds, and you're at 14, I probably wouldn't say, well, hey man, we need to spend a lot of money on this because 14 is too high. No, 14 is not too high. So don't go off on a wild goose chase trying to draw it down to 6 milliseconds, because you will never draw it down to 6 milliseconds ever. So don't try. Don't design something to run at 100%. That sounds a little weird. But if you're designing things so everything on your machine runs at 100%, that's probably, first of all, it's just not at all likely that your email server and your web server and your SQL server are all going to be simultaneously running at 100%. That's probably not the right way. Anyway, observe the effects when you make tweaks. I want to tweak something. First of all, this is like you're trying to diagnose why the car is doing something. It doesn't matter, right? The rules are the same. You don't make like 4 changes and then go, hey, that fixed it. Oh yeah? Which one of the 4 made those made it work? I don't know. So do one change at a time and observe the behavior. Don't do multiple things. It'll just confuse you. Yes, you might accomplish the goal, but you won't learn anything. So make only one change at a time. And then the last rule on doing this is have a fallback plan in case your little tweak here really mess things up. You need to be able to get back the way it was. So, ways to improve performance on page 1073. So there's a bullet list. So the first one is pretty straightforward. Have enough memory. Okay, in a physical machine, that means shutting it down and installing more sticks of RAM. In a virtual machine, I just go up there and go, tweak it a little bit, and presto changeo, I got more RAM. Woohoo! Reduce the use of mechanical hard drives. Switch over to solid-state drives if you can. In a lot of systems, a lot of Windows systems as well, if you were to double the amount of memory on a typical Windows PC, most people would not notice. If you were to double the CPU speed, they probably would not notice that much. But if you swapped out their hard drive with an SSD, yes, they would. Okay, maybe instead of saying double, let's say you increase the memory by 10%, they ain't gonna notice that. Increase your CPU by 10%, they're not gonna notice that. But increase from a mechanical hard drive to an SSD, oh yeah, they are definitely gonna notice that. Okay, you know how this works. We're coming up on the 15-minute mark again.